All right, so here is our document for net ionic equations. It has this read this section here, which kind of explains what's going on. So we're trying to figure out in a double replacement reaction what's actually going on when we have these solutions where we create a solid. So what we're going to do is we write the balanced chemical equation. We use our solubility chart, this lovely red chart, to determine whether or not they're soluble or insoluble. So remember, you look at the negative ion. What is it attached to? So let's say it's nitrate. It's attached to any positive ion, therefore it's soluble, so we would write AQ. All right, so just a reminder, that's where this AQ comes in, nitrate with any positive ion. And so what happens is we write the balance equation, then from there we take we split apart the ions that create this ionic compound. So for example, this potassium, it's going to break apart from chlorine. And so a potassium ion is K plus 1 and chlorine is Cl minus 1. And we notice we have this 2 in front. That big 2 is telling us that, hey, we have 2 potassium chlorides. So there's 2 potassium ions floating about, and there's 2 chlorine ions floating about. So that's how I was able to do this. Same thing here with our lead 2 nitrate that breaks apart. When it breaks apart, breaks into 1 lead 2 ion. That's why I have Pb plus 2. And it breaks apart into 2 nitrate ions. So this is a small little typo on our paper here. This should have NO, should be NO3 with a -1 charge. All right. And then over here we see this one was aqueous, so we have 2 potassium ions and we have 2 nitrate ions, both of them again aqueous. But then we see this solid here, lead 2 chloride, we double check here. So we find chlorine, chlorine plus, and then lead with a +2 charge is in this list. So we look over, it says not soluble, therefore it's solid. All right, so this will not break apart. So when in a solution, this does not break apart, so it stays PbCl2 solid. So then what we do, you notice I have these marks. Anything that appears on both sides of the equation that are identical, we cancel out. So here we have 2 potassium ions, we strike it out. 2 chlorine ions do not exist over here. Lead +2 does not exist in our product side. But we have 2 nitrate ions on both our product and our reactant side. Fix that. And then what we do is we write the net ionic equation, which is everything we did not cross off, because what we crossed off we call those spectator ions. So they just watch the reaction actually occur. So what's left over is 2 chlorine ions, aqueous, a lead 2 ion, aqueous, to make PbCl2 solid. So that is our overall net ionic equation, right? So I've already done one of your examples, but let's go ahead and look at this one. So we have sodium carbonate. Sodium carbonate is Na2CO3 plus iron 2 chloride, which is FeCl2 because we crisscross, +2 -1, to form arrow, sodium chloride, NaCl, and iron 2 carbonate, and the 2's are going to cancel out, so FeCO3. So then we look at our lovely chart over here. So I'm looking at carbonate, carbonate and sodium. Sodium is an alkali ion, so it says soluble. I'm going to go back to over here. I'm going to write AQ. Iron 2 chloride, so I find chlorine. Iron is not on this list, so it's any other positive ion, so it's soluble. So therefore, right here, I'm going to write AQ for soluble. NaCl, announcements. So sodium chloride, we look for chlorine again. Chlorine, sodium is an alkali ion, it's not on this list, so it's anything else, so it's soluble. So I go back over here to our NaCl, write AQ. And then we look for iron 2 carbonate. Carbonate with alkali ions or ammonia is soluble, but anything else is not soluble. Well, we know that iron is not an alkali ion because the alkali ions are here: lithium, sodium, potassium, rubidium, or cesium, like column 1. Iron is a transition metal, it's not there, so it says what did it say? It said not soluble, so we go over here and we write solid. So then from here we write the complete ionic equation where we break them apart, but after we balance it first, because I almost forgot to balance it, we balance it by placing a 2 in front of NaCl and everything else looks stable. All right, so 2 Na aqueous because it breaks apart, plus 1 carbonate ion aqueous, plus this breaks apart, so Fe plus 2 aqueous plus 2 chlorine ions aqueous to make 2 sodium ions aqueous plus 2 chlorine ions aqueous plus, and then this one didn't break apart, so it's FeCO3 solid. And then remember from here, we have to cross off our spectator ions. So I'm going to cross off sodium because it appears twice. It appears on the product side here as well as our reactants. And then carbonate is not on both sides, so we keep that. Iron's not on both sides as an ion, we keep that. But chlorine we cross off because it appears on both sides. So everything else, we're good. So then we're going to write our net ionic equation. It doesn't matter which order you write it in. I like to write the positives first. So I'm going to write Fe plus 2 aqueous, AQ, plus carbonates ion aqueous to make FeCO3 solid. And there you have it. That's our net ionic equation briefly explained for you this morning. Thank you.